Hello, good morning, afternoon, evening. Depends where you are in the world, I guess. Welcome, everyone. There you go. A timer there tells us we need to start. So perfectly on time. Let me turn the timer off. I don't want that. In fact, before I get to there, I'll wait a few more seconds as always until everyone joins in. Let's go from starting soon to. So welcome, everyone. Um, a number of people joining. Some are on Zoom, some are watching the streams, some platform on social media. Doesn't really matter which way you're joining. If you're on Zoom, throughout the session, you're more than welcome to raise your hand. I'll keep an eye, and whoever wants to jump in and ask questions using their own voice, please do so. If you're watching on one of the social media platforms, depending on which one it is, you'd be able to comment. If you prefer to move on to the Zoom option, it's the same thing, right? The same session. But if you're on Zoom, you can ask questions directly. Then go to realpython.com/live and you can swap to Zoom. And if at any point you need to swap to Zoom for whatever reason, you prefer it that way, you're more than welcome. It's the same session, of course. Good. A reminder, so yes, this is being streamed live. Some of you are watching it streamed and it's being recorded. I will share the recording. For those of you who registered and I have their emails, I'll send you an email with the link. For those who are watching on the streaming, depending on where you are, the recording will be either there or I'll share with you a page with resources, including a link for the recording later on. So if, in fact, someone there said you won't be able to watch it all, that's perfectly fine. If you need to drop in and out at any point, or if you can't stay till the end, this might be a slightly longer session, so it might go sort of around 90 minutes or so. If you need to drop off at any point, the recording will be there. So there we go. Um, okay, I don't want to do too long of an intro because I want to get straight to the coding, but a few quick things. Who am I? You probably don't care as long as you get the Python. Anyway, I'm Stephen Gruppetta. I'm one of the core team members here at Real Python, and I'll be with you, of course, for the next 90 minutes or so, 60 to 90 minutes, depending on the project is a bit on the longer side, and then we'll have a Q&A at the end as well. Um, this is a beginner's workshop. So if you have never done any programming before, you're in the right place. If you've done a bit of programming, perhaps you're not an absolute beginner, but you consider yourself closer to the beginner's area, that's perfectly fine as well, of course. You'll find that some of the topics I discuss may not be entirely new. However, one thing I quite like when teaching is not just to show the how to do things, but the why, and to understand things at a deeper level. So even if you've done a bit of Python before, the topics you will hear about again, I'm sure you get to understand them at a deeper level. If, however, you're an intermediate to advanced Python programmer, you're very welcome to stay anyway. But just so that you know what you're expecting, this is a workshop aimed more for beginners. So I'm not going to assume any knowledge whatsoever. Good. It's a hands-on project, so you're more than welcome to watch it as if you're watching a film on Netflix if you want. Get your popcorn and your drink. That's perfectly fine. But the best way to uh, go through this workshop is to open your Python editor and code along with me. I will not go too fast, so you'll be able to keep up with me. If you can't, send me a message in one of the chat, or if you're on Zoom, raise your hand and say, "Oh, can I see something again?" But I will go at a pace where you can code along with me. If you're stuck, you can ask me questions, etc., etc. Um, we have an ambitious project ahead of us today. It's a Python 101 project, right? So I'm not going to assume any knowledge. I'm going to start from the basics, and we're going to cover, or rather, we're going to use quite a few topics. Now, of course, in 90 minutes, there's so much detail we can go into. So we will cover many topics, but we won't cover them in too much detail because otherwise we'll be here for 6, 7 hours rather than 90 minutes. However, I'll share with you some resources later on. I'll do it a bit later so that we can get started. So that any of the topics we introduce today, you'll understand them reasonably well today. But if you want to go deeper, I'll share with you resources so that you can take the next steps after this workshop. Good. I'll do that in a bit. Roughly, it's going to be about Normally it's about 60 minutes. This project will take a bit longer, so we'll probably be more like sort of 70, 75 minutes with the project. Then we'll have a Q&A at the end. But, and this is a very important but, you do not have to wait until the end to ask questions. The best time to ask question is as we go along. Don't worry about interrupting me. You're not going to break my flow. I'm quite used to people asking questions at any point you want. I've mentioned this already. If you are one of those on Zoom, you're more than welcome to raise your hand and ask the question using your own voice. This might give a break to others from hearing my voice on and on and on again. If you're on one of the other streaming platforms, you should be able to type in the chat, depending on which platform you're in, and I'll keep an eye on both the Zoom chat, the Zoom raised hands, and the chat from anywhere else you might be. Good. Let's get going. Nothing, no questions so far. Brilliant. I like that. But do ask questions as we go along. Okay, so we're going to be working on a project. Now, this is not your typical Python 101 project. So it's going to be a visual project. We're going to be writing a game, and I'll show you the game in a second. Incidentally, we have another one of these workshops next week. It will be a different project. It will be more of a classic type of project. And we also had one last week. There's the recording running around there. So if this is not the only introductory workshop, but this one is a bit different. Let me run the one I made before, as they say on the cooking TVs, right? And we're going to be writing a game. Now, we've got 90 minutes. We're starting from the basics. The aim here is not to write a flashy game that we're going to go and sell on an app store. In fact, you can see the graphics are fairly simple. It's fair to say, quite simple. That's not the point. The point here is not to write a flashy game. The point is to learn Python along the way. We're going to build this from first principles. We're going to write everything ourselves. And the way the game works is we've got a target, that's the blue dot, which is always on the right-hand side of the screen. And then we have the green thing, the cannon, if you like, which you can move around. And you can see it's aiming at an angle, and that's the cannonball ready to... Oh, I missed. You get the idea. The aim here is not to write the most exciting game ever, but as we're writing this game, we're going to explore quite a bit of Python fundamentals. Since we are working with graphics, I'm going to be using a tool which is part of Python. In fact, you can see there, it's the turtle package. Strange name, I know. The aim of this workshop is not to learn graphics using Turtle. That's just a tool we are using. However, as we're building this code, we're going to be looking at some really important Python fundamentals. I'll tell you, and you'll figure it out yourself as well, but I'll tell you, the stuff that's specific to the graphics, sometimes I'll go a bit quickly through it because it's not really that important. It's the stuff which is relevant to all of Python that we'll focus on. Okay, ready to go. Let's clear everything. I'm using PyCharm. It doesn't really matter what editor you're using. The Turtle module, if you have some unconventional Python installation, the Turtle module might sometimes misbehave. But if you're using the standard Python, it's all part of the Python you've installed on your computer. Let me check on the chat. No issues so far. So let's get started. We're writing code in Python. Now, Python, like any programming language, comes with lots of commands, let's call them commands for now, ready there for you to use. If you have done 2 minutes of Python at any point, you've probably used the most boring function there is, print. It's also very useful, however, right? So these are tools that are within Python. You can use them straight away. However, Python also has a much larger library of tools to do pretty much everything. If you're doing finance, if you're doing web development, if you're doing data science, if you're doing science, there are libraries there and packages that have lots of tools for you to use. And sometimes we want to bring these in so that we can use the tools within them. And today we're going to use a couple of them. We're going to start with the Turtle module, the one I've mentioned, strange name module, doesn't matter why. It comes from historical reasons, pre-Python. And we need to fetch it into our program. And in Python, we use the import keyword, and we're going to fetch this turtle. It's called a module, but think of it as as a folder, if you like, with lots of commands inside. So we've brought it in, it's now on our desk. So anytime we need to look up something in this folder, it's there on our desk, we can use it. That's what we've done here. We've brought it into our program. And we can now start creating stuff. And the first thing we need is to create the screen in which our game is going to work. And I need to open this folder, the turtle folder. It's a module, right, that we just brought in. I want to pick it up from my desk. That's what I'm doing there. I'm telling Python, can you find this thing you just brought in? And then I want to open it. We'll see the dot often today. In fact, in Python, you see the dot everywhere. In this case, it sort of means open the folder and look inside. And the first thing I'm going to do is to create a screen. And you may have noticed there that when I started typing it in, it auto-completed for me. Your tool probably does the same thing as well. If you are typing it, notice this is an uppercase S, and we have those parentheses. They look a bit weird because there's nothing inside them. And this is going to be something we're going to be talking about a lot. This screen parentheses is creating something in our code. In this case, it's creating a screen. In fact, the technical term for the thing we create is an object. Object is a technical term, but you can think of it as an object in the plain English way. That's what this is doing. The turtle dot is simply telling us, or telling Python, where to find this command. So this line has created an object within our program. Often, we want to give a name to this object. We want to label it. And you can label it anything you want. As long as, well, there are some rules, right? You can't have spaces, you can't have other punctuation marks. But if you just put a string of letters there, you can name it whatever you want. Now, you shouldn't name it that way for a number of reasons. It's hard to type. It's also not very descriptive. So in this case, we could call it window. I often sometimes use window, or just use screen in this case. Notice I'm using a lowercase s here. So it's just a coincidence I'm using the same name. It doesn't have to be, right? So what have I done here? I've created this thing in my program, and I've given it a name. Why does it need a name? Because if I want to refer to it from now on, I need to refer to it by name. For example, I'm going to now say, hey, Python, do you know what the screen is? And it says, yeah, of course. It's the thing you just created on the previous line. Good. I'll come back to this point in a bit, right? Now, every thing in Python, every object can do certain things. Let's find out what the uppercase screen can do, which I call lowercase screen because I'm lazy. So I'm going to put a dot in there, and you can see lots of stuff comes up. Doesn't matter what the order is, right? These are all the things, all the functions that this screen can do. We actually call them methods, but never mind the terminology. And there are lots of them, right? The aim here is not to learn how Turtle works, right? So I'm simply going to give you stuff. But the key point here is that any thing I create in Python, it comes along with things it can do. For example, here I can set it up. So this is something that a screen can do. Whoever wrote the Turtle module said, look, when you create a screen, one of the things it can do is the programmer can set it up. And setup takes two numbers, the width and the height of the window in pixels. Okay, we're ready to run this code, but whenever this is something specific to graphics, right? So I did mention when it's specific to graphics, I'm going to go quickly because I want to focus on what's specific to all of Python. Okay, so someone has asked me there. You tried to run this and you got an error, module not found. If that happened, you are probably using a non-standard installation of Python. You could try installing it if you seem like you're aware installing it with pip. See whether that works. Hopefully it does. So for some reason, the Turtle module and the module you mentioned is one that it's based upon with certain non-standard installations of Python. So depending how you install Python, if it's not there, hopefully, yeah. So the standard installation of Python comes with all you need, Turtle, and the tkinter is the windowing environment. It's how Python talks to the operating system to create windows. Fingers crossed it will work. Now, whenever we have any graphics things, if I run this program, and you can try running this program, and what you'll see when you run it is a window flash very quickly and it will disappear. Why? Because when the program ends, I only have 3 lines of code, right? Here, well, 4 if you count the blank line. By the way, blank lines don't matter, right? It's just a way of keeping the code neat. So don't worry where you put a blank line. Once the code ends, Python says, okay, I finished the code, and it wraps everything up. With a graphics program, I want something to keep the window open until I choose to close it. And with the turtle module, at the very end of our code, we add, so again, from the turtle folder, we brought in the module, turtle.done, parentheses. Notice the pattern? If you've not seen lots of Python before, you'll see the pattern. Lots of things have parentheses at the end. Even setup did. But setup, we also put in 2 numbers, separated by a comma. We'll see the pattern going on. Turtle.done simply keeps the window open at the end. So if you run the code now, you should get, let's see, my computer is taking a while there. There we go. You should get a window. How exciting is that? We've opened a window. Okay, it will get more exciting, I promise you, but just to get us going. So I created this object, which is a screen. I've set its width and height, and turtle.done keeps it open until I close it. And when I close it, the program ends. Okay, so far so good. I'll keep an eye there. No more questions so far. No raised hands, so I'll keep going. I did say I'm going to start slowly, but then I'll speed up as I go along, right? So we'll. Okay, we've created an object so far. Let's create another object. Those of you who are here at the beginning, I showed you the version I made before, and we had, apart from the screen, we had 3 things on our screen. We had the cannon, which was a triangle facing 45 degrees. And then we had the cannonball, and then we had the target. So those are 3 more things we need to create. Let's start by creating the cannon. And once again, I'm going to be using stuff that I find inside this turtle module, the folder I have on my desk. I'm going to leaf through it. And what I want now is to create what's called a turtle. The reason it's a turtle is historical, right? It comes back from, I think, the early 80s or late 70s. It doesn't matter. The turtle is the thing that we're going to create that will move around the screen. We can give it shapes and colors, etc. Notice the similarity. From the module turtle, here I created a screen, uppercase S parentheses. Here I'm creating something else, but the pattern is the same. Uppercase T, turtle, and the parentheses in Python, the parentheses, think of it as do this command now. If you remove the parentheses, it won't give you an error, but it actually won't create this object. You might think, oh, that's weird, right? But you'll get an idea of what the parentheses is doing. This looks a bit strange, right? Because we have turtle twice. This happens in coding, but these are different turtles. The first one, lowercase t, is the module we brought in, the folder with information inside. The turtle with uppercase T is the thing that actually creates something in our code. And as we did before, we need to give this a name. You can call it anything you want, but let's use descriptive names. This is going to be the cannon, which is going to shoot my cannonballs. Let's run the code. And still not very exciting, but now we have something in the middle of the screen. I'm glad to see, Ricardo, you fixed it. Good. So problem solved. This arrow is the turtle. Now, by default, these avatars, these sprites, call them whatever you want, are created in the middle of the screen. The default color is black. The default shape is a boring arrow. We can change all of those. Now, I did promise you that the focus here is not on the turtle module. So I'm going to go a bit quickly here. What can a turtle do? Once again, if I say the name of a turtle, like cannon and dot, these are all the things it can do. One of them is it can change shape. I'm going to use a triangle. By the way, since it's called turtle, one shape you can use here is turtle. If you put lowercase t turtle, you'll get a cute turtle instead. But I'm going to be boring and use a triangle instead. I won't run the code every time, but you can, right? Feel free to run the code and you'll see that now the avatar will be a triangle. But I'm going to do a few more changes before running the code. Cannon.color. Again, these are commands that you don't remember them, right? When you're using a module, you go and look at the documentation, you see what's available, and then when you use it often, you'll eventually remember them. Programming is not about remembering commands. That's the least important part of programming. Let's go for green. And let's run it, see what's happening. There we go. So now you can see that I've done two changes. The shape is now a triangle, not the little arrow I had before. The color is green. You get the idea, right? We can change whatever we want, whatever functionality is available, because these commands are there. I didn't create shape or color, right? They exist already. Canon and screen are the only names I created. The rest exists in Python. And we always want our cannon to be on the left-hand side of the screen. So I'm going to use yet another tool here, set position. No prizes for guessing what it does. It sets the position. So by default, the turtle, you may recall, starts in the middle. The middle is 0, 0. So if I want the cannon to be on the left-hand side of the screen, I need two numbers here, right? The X and the Y. Let's go for minus 50. It's minus because I need to go to the left from the center. And let's go for 0. So it's the cannon is going to be starting off height-wise in the middle, but slightly to the left. And there you go. You might have noticed it's drawn a line as well. That's because the turtle back package is sort of a drawing package. We're not going to use it to draw, right? We're going to use it to make a game, but it's a drawing package. That's going to be annoying if every time the cannon moves, every time everything moves, drawing a line, we'll end up with a whole spaghetti of lines. We don't want that. So what we can do before we move the cannon, the order of things matters in programming. We can say, this is a drawing program, right? So can you raise the pen up? Which means when you move the turtle from the middle to the minus 150,0 position, can you actually raise the pen so you don't draw a line? And in our program, we never want to draw lines, right? We're going to use the items themselves. So whenever we create something, we just put pen up so it doesn't bother us with those lines. Good. And one last thing, apart from position, I also want to set the heading. And I want it to face 45 degrees so that you can see that the cannon is now facing there because I'm always going to shoot the cannonball in that direction, right? You can do whatever you want, right? If you want your version to be different, go ahead. But I'm going to keep it a bit simple. Okay, let me have a look. So far, so good. A reminder, you don't have to wait till the end, right? If you have any issues, those on Zoom, raise your hand or ask in the chat, or those on Facebook, YouTube. Not all platforms have chat available, but depending where you're watching, you should be able to post a comment and it will appear in front of me, hopefully. If technology works. Technology is great when it works. When it doesn't work, not so much. Okay, so far, so good. Now, before I move on, I promise you that the focus here is not on the turtle module, but on what's happening. Things that we're learning about Python that are true for almost every program we do. One of them is this idea of importing modules. Python has such a huge, what's called the Python ecosystem. It has modules about everything. So whatever application you need, you're almost certainly going to find something you can import with built-in tools. Like in this case, I can create turtles that can change shape, change color, etc., etc. The other thing we've seen is how we're creating things. We created two objects so far. And the pattern has been similar. We choose a name on the left, screen, cannon, whatever you want. Then you put an equals. The equals means I'm going to define, I'm going to tell you what this label is referring to. And then on the right-hand side, we create this object. Here's how we can think of this line. The idea of giving a name to an object, we're storing it with a label so that we can refer to it later on. So I like to think of this as a storage box, a cardboard box. Whatever is on the right, the object goes inside the box. That's how I'm going to store it. But then I want to stick a label on the box. And that name is the label I put on the box so that I know what's inside the box. And I know how to find it easily. So if I have 20 boxes on a shelf, 20 boxes on a shelf, because they're labeled, I know how to fetch screen or cannon. Before we carry on, a small aside. So let me open a different coding environment. For this part, this has nothing to do with our project, right? So feel free to just watch in this if you want, or yeah, I'm not going to be doing much. This is what's called an interactive environment. In Python, this has the three chevrons. Doesn't matter. Let me create two more objects. Let me create three more objects. The pattern is the same. Come up with a name, any name you want. I'm going to call this person. equals. Person by itself doesn't exist. If I hit enter now, Python tells me I have no idea what person is. But if I say person equals, it means, okay, I'm going to tell you what person is. And you may have noticed I've used quotation marks for triangle and green, and I sort of ignored it. Let me tell you what the quotation marks are. Let's assume I have someone called James. So what I've done here is inside the quotation marks, that's a way of telling Python, this object is a string of characters. In fact, we call it a string for short. So it's still an object like screen and turtle, but it's a different object. A screen has a certain purpose. A turtle has a certain purpose. A string, which is used much more commonly in Python, has its own purpose. It's a way of storing words or characters. But we can use them in the same way. Remember how with screen we could say dot, and then there were things that the screen could do, like setup. With the turtle, we had shape or color or pin up. Let's see what we can do with an object which is a string. And I press dot there, and you can see they have a different set of tools I can use. I can replace a letter. I can, let's do upper, make it uppercase. So depending on what type of data an object is, screen is a screen object, cannon is a turtle object, person is a string. Depending what it is, we can do different things with it. It sort of makes sense, right? I can change a string to uppercase. I can't change a turtle to uppercase. It doesn't make sense. And yeah, I can change the shape of a turtle, but it doesn't make sense to change the shape of a string. Let me show you two more quickly. Once again, call this anything you want, right? I'm going to call it numbers because, surprise, surprise, I'm going to be storing some numbers. But this time, I've put square brackets there. By the way, the type of brackets we use in Python is really important. I've seen a question there. I'll come to it in a second, right? So I haven't ignored it. The type of brackets or parentheses we use is really important. So far, I've been using the round brackets or parentheses, depending on which part of the world you are. You'll call them different things. Here, I'm using a square bracket. And then I'm going to put some numbers separated by commas. You can put as many as you want. This is what's called a list in Python. So once again, I've created an object. This time, it's a different type of object. It's a list of numbers. And let's see what things we can do with lists. And once again, I have a different set of things there. I'll let you explore them later on. Let's pick one of them. I want to append a number to the list. And now you can see that my list has an extra number. So you can see that depending what type of data we have, we can do different things. Yes, I'm having a look at the questions. So if you have issues with the first line, someone had this problem earlier. So Turtle, if you have a non-standard installation of Python, sometimes it doesn't have for whatever reason, doesn't have the graphics module, the module for Python to deal with your operating system's graphics. I can see someone suggested an option there. Depending on what operating system you have, however, that should work. Give it a go. Let us know if it doesn't. This is one of those, one of the problems with the graphics is that if you've installed Python in a non-standard way, sometimes it can give you a bit of issues. So hopefully not too many of you have had that issue. Good. That's a quick recap. I'm going to speed up now. We've done half an hour. We've covered some basics. Let's now start adding a lot more. In fact, the first thing I'm going to do is I'm going to give you some work to do. I would like you to create a target on the right-hand side of the screen. I'm going to give you a couple of minutes. I don't want to spend too long because I want to keep the workshop moving, but I'll let you have a go at this. There's nothing you haven't seen yet. So far, we've created a cannon. Now we want to create a target. You may recall my target was clue. It was a circle, not a triangle. And now I want it somewhere on the right-hand side of the screen, not on the left. Let me give you a couple of minutes to have a go. I'll deal with questions in a bit, so I've seen them. So we're going to have to create another thing, another object. We need to give it a name, ideally a sensible name so that someone reading your code knows what's what. Pick any color you want to give it, right? And then we want to place it on the right-hand side of the screen. While you're working, someone asked me, why not use Pygame? So Pygame is another of these modules. Pygame is brilliant for doing games. That's not what we're doing here. The aim of the session is not to write a game, it's to learn the basics of Python. Modules like Pygame do all the work for you, which is great if you want to write a game. It's not great if you want to learn the basics of Python. So our aim here is to learn how to program in Python. So Pygame is not great for that. It's great if you already know stuff and it's doing stuff behind the scenes. So that's the reason. So yes, if you were writing a game, if your aim is to write a game, there are better ways of doing it. Pygame is one of them. There are many other modules as well. But that's not what we're doing here. We are, yes, writing a game, but that's not our aim. Our aim is to learn how a Python program looks like. And Turtle is great because it allows us to do things from first principles. So the aim here is to learn how Python programs work. Um, Excellent. I can see that Lebokang, hopefully I pronounced it correctly. Problem fixed. Okay, I'll start writing some code. And if you're writing, um, so James, what of VS Code? I'm having same issue. Um, yeah, so there you go. I can see that someone is answering your question. Uh, thank you. Some of you are helping out. I'll come and have a look later if it hasn't been solved. Installation issues. When you install Python, if you're installing it from the main python.org, you'll never have issues. And that's the best way to install Python, usually. That's the way I use. But some other people have other ways of installing Python, which sometimes has a few differences. Right, so I want to create another turtle.turtle object. And let's call it target. Why not? Good name, right? Descriptive name. When you choose names, there's a joke in Python, but it's not really a joke in programming, that one of the hardest things in coding is choosing names. And you might think, is that really the case? You want to choose names that are descriptive, that will make your code easy for someone else to write. So target in this case will do. Since I'm repeating, let's go for shape. I'll go quickly. But this time I want it to be a circle. There aren't many shapes, by the way. So if you want to try others, there are very few. Let's go for some color. I'm going to go for, I don't know, blue. Once again, I want to use pen up for the same reason as before, because whenever I move it, I don't want to draw lines. Now, set position. You could do what we did with the cannon. Pick an X, which has to be positive, right? Because we want to be on the right-hand side, and the Y, and that's great. But I want to make this a bit more interesting. I would like to pick a random number for X and a random number for Y every time I run the program, so that the target is in a different position. So I would like my program to pick numbers for me. I cannot type in something comma something. Well, I cannot type in number comma number. So this is where I'm going to go back to the modules. Just like Turtle was a module we brought in with lots of useful tools. Turtle had tools to draw on the screen. We're now going to import another module, another folder, if you like, with lots of things in it. And this one's called random. No prizes for guessing what type of information it has within it. It has tools that will allow you to create random stuff in Python. Now, I'm going to split this line just to make it easier. You can keep writing in the same line, right, if you prefer. But just to make it easier for you to see, I'm going to split this line. Let me close this. Um, so, oops. First, set position needs two numbers, x comma y. But I'm not going to type numbers. I want Python to give me an X. So I'm going to say from the module I just imported, so the folder that I can now look called random, I can look inside and you can see there's lots of stuff in there. You may never use some of them, you may use others. I'm going to use the one called randint. You can start typing it in, which stands for random integer. Now that's not enough because so far all we have done is you know, we're fetching a command or a function as it's called from the random module. But this function, we've seen the pattern. Can you see all of these have something in common? They all have parentheses. Then sometimes there's something inside, sometimes there's nothing, sometimes there's a couple of things. Randint is the same. These are functions that do something. They're like the verbs in Python. They do something. Randint needs two numbers, the minimum and the maximum. And then Python will choose a random number between whatever and whatever. So I could say here, let's go. I want this to be on the right-hand side. Remember, 0 is the middle. So let's say that we don't want it to be exactly in the middle, right? We want it to be slightly more on the right. So from 50 to, let's say, 250. This is the first number in set position, the X. So we're saying anything between 50 and 250. A reminder, the width of my screen is 600. So that's minus 300, 0 in the middle, and 300. So 250 is not quite the edge. It's sort of 50 pixels away from the edge. That's my X. But now I need my Y as well. So I need to do it again. Random.randint. So now pick a second number for Y. But now this is the vertical, right? So let's say from minus 200 to 200. Again, my screen is 800 pixels high, so minus 400 to 400. So minus 200 to 200 is not quite, sort of halfway, half the height. Good. Plenty of code there. Let's run the code and see what's happened. Where is it? Sometimes it doesn't show up. And now the target will be in a random position somewhere in this area, right? From 50 to 50 and minus 200 to 100. Every time you run it, in fact, yours might appear somewhere else. Good. We have our cannon facing that way. We have our target somewhere there. What do we need next? We can go a bit quicker now because now we need our cannonball. So once again, let me remove this line. Actually, by the way, I forgot to tell you, earlier, when I gave you a task and gave you a couple of minutes, I actually wrote this comment there. And this line started with a hash symbol. This means we're telling Python to ignore this line. It's meant for human beings. In fact, I wrote this in plain English. This is not Python. This was a note I've written for you. So anything after a hash symbol is what we call a comment. So Python will ignore it. It's there for the human being. We'll see there's another reason we might put a comment in there. So for now, I've removed it. Okay, I'm going to go a bit quicker now because this is going to be similar. Let's create another turtle and this time call it ball because it's the ball that's going to fly. Let us make it a circle. I'm also going to make it a bit smaller, turtle size. Now, for those of you who installed Python in a different way, you may not have turtle size. If this gives you an error, just remove it. Again, it's one of those quirks where if you have the standard Python, it's perfectly fine. But if someone installed Python from some other source, sometimes for some reason, this is not there. And the way turtle size works is that 1 is the normal size, so 0.5 is half the size. So this would be half the size of our target, just because the cannonball should be a bit smaller. But it doesn't really matter, right? These are all turtley things. They're not important. Let's go for some color. You can go for red. I'm going to go for a slightly more interesting type of red, fire brick. There are some strange colors in there, just to use something different. Once again, we want to do pen up. These are all things we've done for the previous ones, right? Because I don't want the ball to leave a line. And I want to set position. Now, I could easily, where do I want the ball to be? I would like the ball to be exactly where the cannon is. So I can go and put those numbers in, -150, 0, and that's perfectly fine. You can do that. But, and this is going to be useful a bit later on, I'm going to use a different logic. Set position needs a set of coordinates, an x and a y. Rather than typing in the numbers, I'm going to do something else. I'm going to say, hey, Python, go and fetch the cannon. Remember, cannon is the label I created for the turtle I'm using as the cannon. What else can cannon do? One of the things it can do is give me its position. Notice that set position changes the position of a turtle. So here I'm changing the position of the ball. Position simply gives me back the position. It doesn't change it, it just tells me -150, 0. So I am setting the position of the ball to whatever position the cannon is in. And this is something we use a lot in Python, where information from one object goes straight into another object. In this case, I want the ball to be exactly where the cannon is. Ignore this yellow warning. It's actually wrong. It works. So you might not have it on yours, so don't worry. Let's run the code. And for some reason, my window doesn't always pop up. And there we go. Hopefully, you have something similar. Yeah, some of you said they have to pop off. No worries. Session is recorded, as I've mentioned. Good. So we have the three things we need here. Well, we have four things. We have the screen, and then we created three turtles. The green cannon, triangle, the target, which will always be in a random position, and you can see that the cannonball is ready to be shot. Okay, so far so good. Good. I think all the questions so far have been dealt with. Let's move on. So we have three objects. Now the fun starts, because now we're going to start moving things. So far, we haven't really moved stuff, right? We created the things and we put them in three different positions on the screen. But now we need the ball to go flying. And this is going to be where the fun starts. So in a game or animation, or even when you watch TV, how do things move? They're not really moving. What's happening is every frame of the animation of the game is slightly different from the previous one. So that when you see lots of frames one after the other, we have the impression of moving. Yeah, I didn't spoil any magic there. We all know that. That's exactly what we want to do when we're writing an animation. So I would like to create things that happen. For example, I want to move the ball a tiny amount, and then again, and again, and again, and again. In this game, we only really have the ball that's moving. That's nice and simple. But in most games and animations, we're going to have lots of things moving at the same time. So what I want is to write some code that deals with one frame of the animation. Do everything that's needed. Move this, do that. And then we're going to repeat it. And then repeat it again. And then repeat it again. And repeating code and programming is one of the most important things. And we have several tools that will allow us to repeat code. One of them, I'm going to write it down because it looks weird, but I'll tell you. Let me write this for now. While true, uppercase T, colon. I'll tell you what all those are. So this is creating what we call a loop. So the code I'm going to write next will repeat itself. Now, it's called a while loop because it starts with the word while. There are other loops, mainly the for loop, which starts with the word for. We won't look at that today, but it's something you learn about, or maybe you've come across already. So the while loop is one way of repeating chunks of code over and over again. Now we're going to keep this simple in today's project. So we're going to put the word true after it. But while needs to be followed by anything that Python can interpret as true or false. It doesn't have to be the word true. We'll see some similar examples later on, so this will make a bit more sense later on. But for now, I'm going to put true. Why? Because the way the while works is, it's every time it repeats the code, it's going to come back and check whether whatever comes after the word while is still true. If it is, it's going to repeat the chunk of code again, and then come back to it. In future work, or if you decide to dive further and go and read the resources that I'll share with you later, you'll see that you can have something else here that can sometimes be true and sometimes be false. That's a way of stopping the loop. But in this case, we're going to keep repeating this forever. And then we'll just manually stop the program when we need to. So that's what while true is doing. And notice the colon. The colon is a punctuation mark that you will see often in programming. We'll see it often today. And that means coming next is a chunk of code that belongs together. In this case, coming next is all the code that I want to keep repeating over and over and over again. And in Python, you'll notice that when I hit enter, the cursor didn't go right to the beginning. It left a bit of a space, an indent. I'll tell you why this is really important. So don't think, oh, that's a mistake. Keep it in place. Good. I want to move the ball. So inside the while loop, each time it runs, it's going to be one frame of the animation. So I want to move the ball a bit, and then a bit more, and then a bit more, and then a bit more. And then later we'll have to do other things, right, as the ball is moving. Now, there are different ways of moving a ball in the turtle package. I'm going to use one which might seem a bit more complex at first than the straightforward one if you've ever used it, but there's a reason why. And it's also more fun. Before, however, I've got a question. Let me open up you should be able to unmute yourself. Is it Lebogang?
Yes, sorry, I think I'm behind, but I was trying to run the code from line 14 to line 21. So what happens is that I can see the circle in blue. So the screen pops up, then I can see that circle in the triangle, which is green. However, it closes and I get an error saying the name random is not defined.
I think you may have line 2 missing, which says import random. Could that be the case?
Oh, yeah, I did not input that.
No worries, but
Thank
that's
you.
actually a great point. So perfect. Why? Because unless we bring in the folder random into our program, then the word random doesn't make sense. So what Python is telling you there is, well, I don't know what random is, but the moment you fetch it from the library, you bring it into your program, then it is part of the program. So whenever you get an error, Python tells you name random is not defined, it probably told you in this case. It means either you haven't created it with an equals or you haven't imported it, such as this module. Good, good, good. Anyone else on Zoom, please do raise your hand and ask questions if you need to. It gives people a break from hearing my voice, which might be a good thing for you. Good. So we're ready to start repeating. So I want to take the ball. Now, you know how you use set position, which allows me to take the turtle and putting in another X and Y position. We also have set X and set Y separate. So if you only want to change the X or the Y, and you'll see why I want to do them separately, then set X only does one of them. Well, set X does the X. So I want to change the position of the ball. But where do I want it to be? The ball is going to be moving. I'm going to focus on the horizontal movement for now, and then we'll do the vertical later. So I don't know where the ball is, right? Because every time it's going to be in a different position. However, what I can say is I need a number here, but I don't have to write the number myself. I can get Python to work it out for me. See how we're going to do it. I'm going to ask the computer to find, so ball is once again the turtle name. One other tool, the turtle module has lots of tools, right? You see shape, turtle size, color, pen up, set X. Another one is X-core, which stands for the X coordinate. This is the same difference as between set position and position. Set position changes the position, but needs X and Y. Position tells me where the turtle is, X and Y. The names are different here, but these are the same thing. Set X changes the position of the ball, X score just tells me where it is. So if the ball is in the middle, X score will be 0 or wherever it's going to be. But I want to move it by a bit. So maybe I want to add some number here. This means that wherever it is, I'm going to move it by 3 pixels to the right. And next time, I'm going to move it by 3 pixels to the right. Now, why 3? In fact, depending on what computer you have, you may need to change this number. For some of you, this is going to be too fast when we run it. For others, it might be too slow. So we want to change this number to suit how fast the ball is moving on your screen, not mine. So to make it easy to change this number, rather than typing in the number here, let us create another label, like we've done with ball and target and cannon. Let me do this here at the top. Doesn't really matter where we do it, but after the import is a nice place to do it. Let me call it ball x velocity. You can see it's underlined in red. In fact, let me run this code. Red underlining, as every teacher has done before, means there's something wrong there. But let's run the code and see what happens. And this is the error message that you mentioned earlier when you joined. It was about random, but it says name ball x velocity is not defined on line 4. Python is telling me I have no idea what this is. That's why I need to put the equals in this case. And by the way, I mentioned that you can call this anything you want. There are some rules. You cannot have spaces when you come up with a name, and you cannot put any punctuation mark except the underscore. The underscore is the only thing you're allowed to put in there, which is a punctuation mark. So often we use it instead of a space. I'm going to use 3 in my case, but you may want to change this to whatever suits you. Timeout. I'm going to make a change in my setup. You don't have to do this, but I'll tell you why I'm going to make this. I'm going to split my screen. I have the same code on the left and on the right. Why? Because I'm going to start scrolling now, and sometimes you may want to see what's at the top of the code. So this way, I'll keep the one on the left showing the top of the code. The one on the right is where I'm going to make changes to the bottom of my code. This hopefully makes it easier because you can see more of the code. You can see that on the left here is lines 1 to 25, 27, whereas here it's going all the way to 35. Hopefully this makes sense, right? So this is just to make it easier for you. So I've added on line 4, I defined a new name, ball x velocity. Call it whatever you want, right? Maybe you want a simpler name. I made it equal to 3. Now, when I set the ball's x position, I want it to be wherever the ball is now, plus, instead of 3, I can now say ball x velocity, the label I've used for that number. Happy with that? Yeah, no questions in either chat. And surprise, surprise, I can do the same thing with y. So set y, ball.y core. Notice that we have parentheses here again. The parentheses, I've mentioned this before, are a way of telling Python, do this command. These are what we call functions, or sometimes we call them methods, but functions is good enough for today. And the parentheses means I want you to do this. So even when there's nothing in the parentheses, we still need those parentheses. Plus ball y velocity. Oops, I don't mean to do that. I meant to do y velocity. But can you see it's underlined in red? Why? Because I haven't defined it yet. So now I can go back to the top of my code, which in my case is on the left, and I can say ball y velocity equals, I'm going to make it equal to 3, right? So the ball is going to move the same horizontally as it does vertically. Let me run the code. There we go. And can you see the ball is moving in diagonally? You may have seen it jitter a bit and jiggle around. It may be more obvious if I make larger numbers here. Let me go for 7 and 7. Oops, sorry, that's too late. For some reason, the window doesn't always appear. Yeah, could you see it there? Sort of, that's not how balls fly, right? Last time I've seen a ball fly, it didn't do it this way. Why? Because how am I moving the ball? I'm first moving it horizontally, and then I'm moving it vertically. So it's sort of moving as a stir pattern. We can fix this. Now, this is something specific to graphics and the turtle module. So I'm going to go through it quickly. Doesn't matter if it doesn't make too much sense, right? I'm trying to keep an eye on time as well. This is something we do with the screen that we created. We can say, at the moment, every time an object moves, Python, the turtle module, displays it on the screen. So we saw it move horizontally and vertically. I can say screen dot, this is a rather strange command, tracer, and I'm going to set the tracer to 0. This means I'm asking the turtle module, every time I move an object, don't display it on the screen. Do it behind the scenes. Why? Because displaying on the screen is normally what takes time, and sometimes I want things to happen behind the scenes. But at some point, I want to update the screen. And in our case, we want to update the screen every time the while loop finishes doing its thing. Remember, each time the while loop will run, it's one frame of our animation. So at the end of the while loop, I'm going to say screen.update. This means whatever stuff you've done behind the scenes, now, when I say update, I want you to refresh the screen. Important. Notice how there's this indent. This, by the way, the blank line is not important, right? I've kept it there just to make it look prettier and to make it easier. The blank line is not important. What's important is this indent. So when I say while true, how does Python know which lines to repeat over and over again? It's all the lines that have this indent. 35, 36, 37 is blank, and 38. Notice how this one doesn't have the indent, so it's not part of the loop. So that's where the indent is really important. Whenever there's a colon, the way we show which lines belong to the same block of code is by giving them all the same space, the same gap, the same indent. Okay, um, let's run the code now. And there we go. I moved to it when it had already gone off the screen almost, but hopefully yours, you can see it move. If your ball is going too quickly, in fact, I've got 7 there. I should have had 3. But if yours is going quickly, make these numbers smaller. Make the velocity 1 or even 0.5 or 0.2 or whatever. Keep making it smaller until you have the speed you want, right? Good. In my case, I've got a ball going off in that direction. Now, last time I tossed the ball, that did not happen. The ball started going off in a direction, but then it sort of looped down. Why? Because gravity is pulling it down. Let's put this in. But don't worry, we're not going to be doing lots of physics here. We're going to keep it nice and simple. So I'm going to add another label. And these are, by the way, we call these variables. The things I create before the equals, we call them variables. They're the labels we use for objects. These are objects as well. They're numbers now. Remember, I had the screen object, I had the turtle object. Earlier, I showed you a string and a list. These are numbers, integers in this case. And gravity is equal to, now this number again might be a number you have to play with depending on how your code works. On different computers, these numbers will be different, right? So I'm going to put minus 0.05. What does this mean? How does gravity work? There we go. Let's do some physics. Every time the ball moves upwards, I want to pull it down a bit. Now, what does that mean? That means every time the ball moves upwards, I want to take its y velocity. The x is not affected, right? It's only the y. And change it. And I want it to be equal to whatever it is now, plus whatever gravity does to it. Notice I've put a minus there, right? So this means that if the velocity, in my case, the y velocity starts as 3. So the ball is moving 3 pixels every frame. The velocity is 3 pixels per frame. But after the first frame, I'm going to change the velocity to 3 minus 0.05, so 2.95. So the y, it's now going to move slower upwards. Next frame is going to be 2.90, and then 2.85, and then 2.80. That means it's slowing down. And if I run it now, could you see the ball going up, but it's being pulled down? So that's all we need to do to create a nice trajectory of the ball going up and down. Good. It took us a while to get here, but we actually can speed up now because we actually have quite a lot done, and a few things will repeat now. Yes, Derek asked me, will the final code be shared at the end? Yes, I will give you a link with resources for you to read further, a copy of the code, and a link to the recordings of the session. So I'll share that with you. And you're on Zoom, so I'll send you an email. Those who are on Zoom, I have your emails. I'll send you an email with this link. Those who are watching um, on the streams, I'll show you the website we need in a bit, or if not, contact us at Real Python somehow and we'll give it to you. So I'll give you the link in a bit. Okay. We have now, let's see where we are. We have created three objects and the screen, the cannon, the target, the ball. The ball is moving and it's moving in a trajectory. Great. A couple of things, well, a few more things we need to do. We need to um, move the cannon. We need to be able to move it left, right, up, and down because we need to adjust where it goes. Otherwise, how can we play the game to try and hit the target? But there's something else we need to do. At the moment, when I run the code, the ball just starts off flying. We don't want that. We want to have control on when the cannon shoots the cannonball. So let's see the logic we need to use here. Which lines of code are moving the ball? Lines 36, 37, 38. At the moment, they're happening in every single frame of the game, from the very first one. Why wouldn't they? I would like Python to make a decision for me. And decision making is an important aspect of many Python programs. Like all Python programs will have some sort of decision at some point. So I would like to do the following. I would like to say only run these lines if I have told you so. It would be nice if that's all we need to do, right? Let's do this into two bits. First of all, when I tell you so, in my case, is when I press a key on the keyboard, let's say the spacebar. And the turtle module gives us a way. I'm using this screen, which is where all the game is being held in the screen, right? It gives us a command called on key press. Incidentally, if this doesn't work, this is for those who maybe have had issues with Turtle and you installed in a different way. Use on key instead, only if this doesn't work. So if on key press gives you an error, use on key. Now, on key press does the following. It will take some Python command, such as shape or turtle size or color, but we'll see what command we need. For now, I'm just going to put 3 dots as a placeholder, right? And it links that command to a key on the keyboard. In my case, I'm going to use the space bar. So string space, all lowercase, is the symbol, the label that's used for the space bar. And by the way, in the turtle module, when we want to use keys to interact with the program, we also need to turn on the listening capability, right? By default, the turtle module doesn't waste resources listening for key presses. So listen with the parentheses says, I am going to be using the keyboard. I want you to pay attention for any keys I'm pressing. Good. What do I want space to do? Wouldn't it be nice if I had a command or a function, as we call it, called shoot? That's what I want to do, right? Unfortunately, squiggly red line. You know what's going to happen there, right? If I run the code now, it's going to tell me, on line 35, name shoot is not defined. That's a shame. It would be nice if there was a command, a function, and we call these functions, right? The verbs of the language. Luckily, in Python, we can create our own commands. We can create our own functions. We can define our own functions. So I'm going to do this just before I need to use it. And the way we define functions in Python is using def, which is short for define, right? And I want to define a function, a command called shoot. Now, you've seen this before, right? These functions have parentheses at the end, almost always. Although notice that inside onKeyPress, I did not have parentheses. It's important we don't put them. Why? Because here I only want to use the name of the function. The parentheses say, do the function now. I don't want to shoot on this line. I simply want to connect shoot to space. So there's no parentheses there, but you will have it everywhere else. And once again, we have the colon. We've already seen the colon once. The colon means coming next is a chunk of code, in this case, that belongs to the definition of shoot. This is what shoot is going to do. Okay, we don't know what's going to happen yet, right? So we need to figure out how to make the ball shoot. So for now, I'm going to put 3 dots. By the way, 3 dots is valid Python code. It doesn't do anything, but it means you can, it's a placeholder. You can put it there because you're going to add some code later on. Okay, the next couple of lines I'm going to write will be incorrect. We'll fix them later, but I think it's important to do it the wrong way first. And this is a slightly more intermediate topic, so I might go through it a bit quickly and then refer you to the future when you understand it a bit better. Ideally, I would like to have a switch where I can tell Python the ball is currently moving, and therefore I want you to run these 3 lines of code. Move the ball horizontally, vertically, and gravity should pull. But then I can turn the switch off and say, okay, the ball is not moving now. So perhaps I could create, we've created many of these variables, right? These labels. I can say ball in motion, and I could start off with false. We've already used true before. True and false come together, right? Uppercase F. This means I'm storing false. True and false are what we call Boolean data types. Just like we had strings and integers and turtles, this is another type of data. Now, why did I start off with false? Because the beginning of the game, the ball is not moving, right? So here I could say, I only want these 3 lines. I want Python to make a decision for me. Should these 3 lines happen or not? And whenever I want Python to make a decision, I can almost ask in the way we would in English. If ball in motion, once again, there's a colon. What happens after a colon? I need to find a way of telling Python that it's this line, and this line. They are the ones that go together. So notice I've selected them all. I want to add an indent in front of all of them. There's a shortcut for this. Select them all, press tab. It saves you having to put the tab in front of each one of them. This means that if ball in motion, and what Python is doing here is checking whether this is true or false. If ball in motion is true, it will do these 3 lines of code. But I'm starting off with ball in motion false. Why? Because in the beginning of the game, in fact, let me run the code now. Where is it? There. You can see that the ball is not moving now. Why? Because I've set ball in motion as false, and Python is checking whether ball in motion is true or false. If it's false, it will ignore lines 45, 46, and 47. That's what it's doing now. Now, this is where I told you this code doesn't work, and because what we should be doing, maybe, is to say, when I call shoot, so when I press space and Python calls the function shoot, maybe I want ball in motion to be equal to true. This makes sense, but, and this is a bit more of an advanced topic, so I'm going to talk about it in 30 seconds, but when you dive a bit further into defining functions, and I'll share with you resources where if you want, you can do that, you'll dive into this a bit further. When I create variables such as ball in motion, target. I'm creating them in the main part of my program. I like to think of it as my desk is my program. I'm putting them on my desk, right? So they can easy to find. When you define your own command, when you define a function, it's as though you're creating a mini program, which is in part self-contained. So when I say ball in motion equals true, Python understands something different here. Because this line is inside this mini program that's defining a function, it creates another one. This ball in motion is not the same as that ball in motion. Now you might tell me, but it's in the same program and I'm using exactly the same name. But that's something special about functions. Anything with define inside the function, anything with an equals, only exists inside the function. So Python looks at this and says, I've got one ball in motion on the main desk, the main one, and then I've got another one in this other area. That's not what we want, right? We want to use the same one. Don't worry if this doesn't fully make sense. This is a topic you'll explore as you move further in your Python journey. But the the solution I'm going to use for this is a nice one because it helps us think how Python works. Instead of creating ball in motion as a label in my main program, I am going to attach it to something else. I'm going to attach it to an object I already have. I've got several objects, but ball is the one that makes more sense, right? Because ball in motion belongs to the ball. So how can I attach this to something else? And the answer is with the dot. We've used the dot many times, right? Why? Because these commands are things that a ball can do, the turtle can do. They are attached to it. These are commands I didn't write. But I can also create my own label, but attach it to something else. I did mention this is a bit more advanced, but I need to use it in this. This is a bit of an ambitious project, right? So I needed to use it. Don't worry if it doesn't fully make sense. So now, ball in motion is still a label referring to false, but it's not standing alone on the desk. I've attached it to another object, glued it together to ball. Why does this matter? Because if I do the same thing there, I am not creating ball inside shoot. I'm simply referring to it. So even though this is a self-contained program, it can still access what's outside of it. So in this case, Python says, you're referring to that same ball. And you're looking inside it and looking for ball in motion. So this is now the same. This label is the same as that label because they are attached to the same object. This is a bit complicated, right? And I'm happy to expand further in the Q&A if someone wants to know more. But so that works. There's one more place I need to do this. Remember, I used ball in motion on line 44. Ball in motion doesn't exist by itself now. It's attached to ball. So I need to add ball dot ball in motion. In fact, you could have called this in motion, right? But it doesn't matter. You can call it whatever you want. Drum roll. Let's see what's happening so far. Let me run the code. So the ball is not moving, but if it works, when I press space, the ball should fly out. 3, 2, 1. And when I press space, I've shot the ball. I'll pause there a bit. We are covering a lot in this workshop. I did mention in the beginning, this was an ambitious project to cover as a first project. But I think it's also fun because it's very visual. So I wanted to try to fit it into a session. You should be able to see all of my code there. Let me pause here for a second. We've got a few more things to do, but I promised I'm going to share resources with you. Where do I want to go? I'll come to this one in a bit. So we also have a present for you, by the way. The list of resources and all the things you need after this session are at realpython.com/live/goodies. I'll post it in the in the chats for those who have access to chats in a second. And the present is you also get a 7-day free trial to get access to everything at Real Python. So, and I'll talk about the forum in a bit, where after this workshop, we can carry on discussing this project if you want. With your 7-day trial, you get access to the members forum, tag me there, and we can carry on discussing this. This page looks like this. Yeah, that's your free trial. But then I did mention I've curated some resources for you. So these are the topics we're talking about, right? We've talked about defining functions. So the tutorial is written if you prefer to read. These are fairly detailed tutorials, right? So this is if you want to go quite a bit in depth. So don't worry if some of these things, you might need to come back to them several times. So that's if you want to understand more about defining your own functions. If you prefer video courses, and this is something you can use with your free trial, then you also have, normally the video courses are a bit more compact as well, and they cover a bit less. So they're more manageable, more ideal for beginners. And there you'll have, you can follow them as video courses. So these are there you go. We've talked about the while loop, we've talked about the if statement, we've talked about variables and objects. That's where you can find resources. The code we're working on is there as well. Although I'll give you some exercises at the end. Before you look at this code, work on the exercises by yourself. That's always good practice. Further down, you'll have links to the recordings once the recordings are processed. Okay, I've got a question there, so I'll go back to my code. Before I go to the code, a reminder, that's realpython.com/live/goodies. I'll post it in the chats as well later on. Question. Where do we define ball in motion? So there are 3 places I'm using it. First, I'm creating it. Can you see the section here? This is the section which is dealing with creating the ball. We create the ball object. Then I've changed it to a circle, made it smaller, changed its color, changed its pen up position. And it doesn't have to be here, but it's a good place to put it because it's where all the ball is being initialized. I'm creating ball in motion equals false, but attaching it to ball. So notice line 34. Ball in motion equals false. This is where I'm defining it the first time. And I'm saying at the beginning of the game, the ball is not in motion. That's why it's false. But then the shoot command changes it to true. And then I'm using it on line 44. This is where Python makes a decision. Is the ball moving? If it is, I need to run these lines. If it isn't, I will ignore these lines. And from line 44, it will jump straight to the next one, line 49. James, my screen should be shared. Zoom is telling me I'm still sharing the screen. I can also see it on the stream. Could it be that the window has moved somewhere else on your screen? I think if anyone else on Zoom can't see the code, can't see my screen, let me know. But I think it might have jumped somewhere else on your screen. So maybe check all the Zoom windows and somewhere it should be there because Zoom tells me I'm still sharing my screen. Good. We've got, oops, there we go. That's where I want to be. So a few more things. We're almost there. Well, 12 minutes to get to, yeah, that's perfect. So far, we have, let me run the code again. I have the 3 objects I've created, and the moment, yeah, I can see the, yeah, perfect. People are telling me it's all fine. The moment I press space, the ball flies up and moves down. There are 2 more important things I need to do. I need to be able to move the cannon left, right, up, and down. I'll do one of them with you, and then I'll leave it as an exercise for you to do the other ones because they're going to be once you know how to move it left, you know how to move it right, up and down. That's one thing we need to do. And then we need to detect whether the ball hits the target or not and do something with it. I've got a question there. In my computer, the movement of the ball is too fast. If the movement of the ball is too fast, these are the numbers you need to play with. Initially, the velocity x and y go for much smaller, 0.2, try 0.1. And then if it's too slow, um, once you change those, you may need to change the gravity as well, because if this is too high, the ball will sort of fall down straight away. Or if it's too low, it will never fall down. So play with those numbers. That's if you want to change the speed of the ball and the trajectory. So those are the three numbers you want to play with. And that's why we define them up there. They're easy to change because they're all at the top, easy to find. Good. Let's start by moving the cannon. And we can do this quickly because you see this is something we've done already. The logic is the same as we've done here. So I want a certain key on the keyboard to, to do something. For example, I want to move the cannon left. Notice that move left does not exist. It's underlined in red, but don't worry, we'll fix it. And the key I need is the left arrow key. For reasons I've never understood, whereas space is all lowercase, the arrow keys, left, right, up, and down, have an uppercase first letter. Don't ask me why. So left is a capital L, uppercase L. So what have we done here? We have linked, we have bound is the word we use, the left arrow key with the function, the command move left. The problem is that move left doesn't exist. No problem, we can define it. Same as we've done with shoot. Move left, parentheses, colon. You can call this anything you want, right? But move left seems sensible, or move cannon left if you want. And now, the lines with an indent are going to be the definition of move left. What do I want move left to do? I want to take my cannon. I'm going to do the same thing we did with the ball, right? There are different ways of moving it, but I'm going to set the X position to wherever the cannon's X position is now. Now, if I want to move left, it's going to be minus. And I'm going to cheat here. I'm going to hard code the number 10. But exercise for you later is to do the same thing we did there. You remember how with the velocity, we didn't write in the numbers in our code. We created ball x velocity, ball y velocity. I'll leave this for you to do afterwards. We might also want to do something like this, right? Cannon step, or whatever you want to call it. Because we don't like to put hard-coded numbers in our code. But to keep things simple, I'm going to put in a 10 there. That's all for now. In the version of the code I'll share with you, you'll see I have a slightly more refined version of this. But in the interest of time, let me stop there. So now, the left arrow key is linked to the command move left. And the command move left, I have just defined it to be take the cannon, change its X position to wherever it is now, minus 10. Let's run the code. And the left arrow key. Okay, so it works, but I have a problem. I also want the cannonball to move with the cannon, right? So maybe what I need to do here is to say, okay, let's also move the ball then. Ball dot set X. Now I have a choice here. I can either do exactly the same thing, right? Move it by 10 pixels. Or I can use a trick we've also seen. Oops. Set the ball's X position to whatever the cannon's X coordinate is. A reminder, set X is the one that changes the position. X score, X coordinate, is the one that simply fetches the value. So we're saying wherever the cannon is horizontally, that's where I want the ball to be. And now, when I press the left arrow key, the ball is moving as well. And then, of course, space will shoot the ball. I hit the target, yay! But nothing happened, of course. That's the last thing we're going to do. Your homework, make the target move right, up, and down. The arrow keys are left, right, up, down, always with an uppercase first letter. So I'll let you have a go at that. If you have any issues, come and find me either on social media or on the Real Python forum with your trial, and we can carry on discussing it there, right? So in order to aim to finish in the next 5 minutes, my target only moves left, but you can make yours move left, right, up, and down. One more thing left. Well, there are more, but one more thing to finish off, and then I'll let you explore the final version of the code I'll share with you, which might have a few more flourishes and bells and whistles. I need to detect when the ball hits the target because I need to do something in the game, right? If we're doing points, you want to add a point. In my case, I don't care about points. What I want to do is if I hit the target, I want to create a new target somewhere else. And what happens to the ball when we hit the target? We want to reset it to its original position, where the cannon is and a few other things. So, how can I do this? And once again, this is a decision that my computer program needs to take. We've already seen a decision. That's the if statement. If means I need the Python program to decide whether to do something or not do it in this case. And now I want to ask Python to do another decision. Notice I'm still inside the while loop. Why? Because this is something I need to do in every frame of the game. Every time the ball moves, I'm going to check whether it's hit the target. No. Move the ball again. Check whether it's hit the target. No. And I keep checking. So once again, I need an if. But if needs to be followed by something that is either true or false. In this case, ball in motion, you may recall, was, where did I create it? Either true or false, because I'm actually changing it to true or false. Here I'm going to do something different. I'm going to use another tool that turtles have, ball.distance. This allows me to find the distance between a turtle and another one. I could have done target.distance ball. It doesn't matter because there are two turtles, right? The distance from one to the other is the same as... This gives me a number. 52 pixels, 27 pixels, whatever it might be. Wherever the ball and target is going to give me the shortest distance between them in pixels. That's a number. If doesn't want a number, it needs something which is true or false. Now, it would be tempting to say, I want to check that this number is equal to 0. That seems to be logical. Unfortunately, in programming, Python will take us literally. So that would mean it has to be exactly 0. 0.000000. It can't be close because if I say it's equal to 0, it has to be exactly 0. In this case, we have things moving around. It's unlikely it's going to be exactly 0. So another way of doing it is to say, if it is close enough, if the distance between the ball and the target, the middle of the ball and the middle of the target, is less than a certain distance, 20 tends to work well with turtles because that's the default size, the default radius of the avatars that are created. But you can try this with trial and error, right? If it's less than a certain number, then it's as good as the ball has hit the target. And Python sees that and gives me a true or false answer. If this distance is less than 20, it's going to say true. If it's not, it's going to say false. And that's how Python is going to decide whether to do the following lines of code. So, if the ball has hit the target, which means they're close enough together, what do I want to do? I'm going to do some copying and pasting here, right? Because I'm lazy. I want to take the target and move it to a new position. Remember these lines that find the random x and the random y? I'm going to paste them there. Notice the indents are a bit funny here, right? Because now this is inside the while loop, so it has one indent. This has two indents because it's inside the if statement, which is inside the while loop. And this is just for showing them on separate lines, right? So you will get used to these indents in Python. Okay, so if the ball has hit the target, move the target. But what else do I need to do? I also need to take the ball and put it back. It's just hit the target. I want to put it back where the cannon is. And we've done this, right? Set position of the ball to wherever the cannon is. Position. Remember the parentheses. There's one other thing we need to do. Well, there's probably more, but to keep it simple. Remember that when we shot the ball, we were changing the ball's y velocity. As it was moving, the ball's velocity was changing, so it's falling down. Now I want to reset the ball back to the target. So I also want to reset the ball's y velocity. I'm taking some shortcuts here to keep it a bit simpler. As you learn more programming, some of these things you'll find even more efficient ways to do it then. But in this case, let's take the same number we had before. In my case, I had 3 in the beginning. So I'm going to reset it to 3. So see the logic there. If the ball hits the target, what are all the things I need to do? Move the target somewhere else. Take the ball, reset it to its initial position, place it where the cannon is, and change its y velocity back to what it was in the beginning. The x velocity never changes, right? So that's okay. Let's see. Now, this is going to be hard to play because I can only move the cannon to the left, right? I can't move it to the right. But let's see. No, I didn't get that. By the way, one of the homeworks I'm going to give you is to also reset the ball when it leaves the screen. So there, it just left the screen. There's 2 places the ball can leave the screen. The right-hand side edge or the bottom. We also want to reset the ball. That's your homework. Let me try again. I'm not sure I'm going to make it from there. And I can't move right? So in the normal game, you'd be able to move right and up. Here I couldn't. Maybe you've managed it already. Yeah, there we go. Could you see there? Now, can you see I have a problem? Sorry about that. I think Zoom decided to have a break there. So those who are on Zoom, hopefully you're back. And the streaming is still working. So hopefully you're all still there. We've almost finished right now. Let me go back to technology. So what I was saying before it cut off, for some of you at least, is that we still have, when I pressed shoot, ball in motion was still true. So now, when the ball hits the target, another thing I want to do is to change it back to false. Good. I had, now let me bring back, because Zoom decided to, let me put the chat back up. Sorry, the screen is not being shared there, right? My apologies. Um, I think someone was telling me that in the chat as well. Why did Zoom? There we go. I need to reshare the screen. What I did in the, there you go. I added this line. I was talking through it, but my screen wasn't shared because Zoom decided to reset on me. I don't know why. Why did you do that, Zoom? This is all I had to do. Why? Because I still had ball in motion through. So this means that when I hit the target, the ball was still moving, so it kept going on and on and on again. But now I'm resetting it to false. Good. We had some technical issues right at the end. Hopefully that doesn't cause too many disruptions. Good. Um, right. Yeah, Tapan, thanks for that. I think the streaming software we're using It's being a bit temperamental today. Last week it seemed to work perfectly. Today it decided to, who knows why. Maybe it's the summer weather, you know. Who knows? Software doesn't like the summer. I don't know. Hopefully you're all back there, can hear me, etc., etc. Good, good, good. We have reached the end of. So what I'll do is I had a question there that I want to miss. Um, yeah, that's fine. On Zoom, I can see. Yes, I had frozen. You lost me, but I came back. Good, good, good. And on the other chat, Ziad, you had a question there. Did you want me? Let me know, Ziad, if you wanted me to explain something again. You're more than welcome. In fact, this is the Q&A now. So I've finished my main demo workshop. Your homework. A few things I want you to do. First of all, finish off. Currently, we can only move the target. Sorry, we can only move the cannon left. I want you to move it right up and down. Otherwise, it's very hard to play this game, right? It's we need the on key press to link the right up and down key with new commands, and then the rest is very similar. Just make sure you get the Y's and the X's and the pluses and the minuses correct. Bonus, I would like you to also add another decision for the program so that when the ball leaves so if I don't hit the target and when the ball leaves the screen, there are two places it can leave the screen, either the right hand edge or the bottom edge. I also want to reset the ball, not the target, just the ball, so that the ball goes back there, and then I can try again, move the cannon and try again. This is yet again a decision I need to make. It's very similar to this chunk of code. Not identical, similar. But instead of checking whether the distance between the ball and the target is less than 20, I want to check where the ball's x coordinate and y coordinate is. I'll leave it there. Have a go. If you then have questions and issues, come and find me on social media or come and find me on the Real Python forum, which you can access with your free trial. Good. Time for the Q&A. I think I've answered all the questions I have so far. While you think about your questions, let me go back to this page to remind you. I'll show you this at the end as well, right? The resources I've compiled for you, as well as the final version of the code, but do not look at the code until you've tried your task. Plus the recordings, the links to the recordings eventually when Zoom decides to prepare them for us, are at realpython.com/live/goodies / whichever way it is. I never know whether Zoom swaps it over. Anyway, you know what a / looks like. And there you'll find all of your resources. So that's the site, that's this URL you need. Any questions? I know we've covered a lot. This was an ambitious project. There's plenty happening there. Let me go back to the code there. It was a very dense 90+ minutes. Take your time to digest it afterwards. But if there's anyone who has any questions for me, either about the code we were working on or about the topic we discussed, or about using real Python in general, or anything you want. You can ask me about the weather if you want. It was nice and sunny and it's dark now because it's evening if you want to know. I'll have a look at my two chats. If anyone on YouTube or LinkedIn or Facebook, you can ask questions there. Anyone on Zoom, or maybe everything is clear and perfect. You have no questions, or maybe you still need some time to digest what you've done. I'll wait a few more seconds in case someone is thinking, oh, I'm typing. Wait, I'm going to enter. So don't worry. If not, I will remind you. Let me go back to there. Next week, there is another different workshop. It will not be a turtle-based one. It will not be graphics. So it will be a bit more, maybe a bit more of a classic type of Python 101. This was an unusual first program, but hopefully you've enjoyed it. So if you want to come back for another workshop next week, it's still a beginner's workshop. So it doesn't follow on from today. It's a standalone workshop, but it's a different topic. So you're more than welcome to come next Wednesday, same time, same place. Wherever you watch the stream this time, it will be there next time as well. And if there are no more questions, I will let you go and carry on with your morning, afternoon, evening, or night, as it happens, wherever you are. And hope you enjoyed the game. You can now play the game once you finish it. We can then compare high scores. Come and find me on social media. If you use the 7-day trial, which I suggest you do, you'll be able to get access to the video courses that I've shared with you. And come on the forum, tag me, say hello, and show me your code. And I will then maybe see you next week if you're available next Wednesday. Good luck with your Python journey. I'm glad you enjoyed it. Excellent. And see you around in the virtual world. Bye bye.